Everyone, welcome back to this video wherein we'll be discussing all the homework questions from your lecture 2 part 1 on divisibility. The 10 odd questions that I've given you, we would be solving all those questions. And this particular video, the audio would be in English. You've already made a video wherein the audio was in Hindi. This same content, there's no difference in the content that you would be taking or the questions that you would be dealing with. Just the difference is in the audio, as some of you were asking for it. Alright, starting with the first question that we have on the screen. If the 11-digit number, and we have the number here, it has two missing values, M and N, these are small letters, but they would be replaced with a possible value of a digit, right? But there's a condition. This number is divisible by 72. So rule of 72 says if a number is divisible by 72, it must be divisible by 9 and 8, because 9 and 8 are co-prime factors of this number. So any number that is divisible by 72 must be 100% cases, it must be divisible by 8 as well as 9, both. So what we'll do, we'll start by checking the rule of 8 and then we'll check the rule of 9, and with the help of these two we can easily find out the value of M and N, and once we have the value of these two digits we can put it here and get to our solution for the expression. I hope you have the flowchart with you. Now, what does the rule of 8 say? Rule of 8 says we only focus on the last 3 digits of the number. And if the last 3 digits of the number is divisible by 8 or in the form of 8n, which is a multiple of, what is 8n? 8n is simply represents a multiple of 8. That is, it could be 8 into 1, 8 into 2, 8 into 3, something like that, right? So I take out 6, 7 and n because these are the last 3 digits and the number that we have is 6, 7 and n. Now just think of a multiple of 8 which starts with 6. So it's 64. So I'm writing here 4. That means this 7 must contain 4. Now what do we have here remaining? 3. Now think of a multiple of 8 that starts with 3, and the only multiple that you can think of is 32. So naturally the only possible value left for n is 2. Do you follow this? Now let's write it like this. We have 672 by taking n as 2. Just check whether it is divisible by 8 or not. If you divide this by 8, 64, you are getting the remainder as 332, remainder is 0. So 672 is completely divisible. Can you think of any other value for n? No, it is not possible. Therefore, we are 100% sure that the value of n would be 2. Suppose we had another possibility of n. Then we would have taken that into consideration. Let's say this is first case, that would have been the second case, and with that we would have proceeded further. Right now I have the exact value of n, so what I'll do, I'll write the number again, and this time I'll replace the value of n with 2. So we have 5, 6, 7, m, 4, 3, 2, 6, 7, and in place of n I'll write 2. Now, this number must also be divisible by 9. What is the divisibility rule of 9? The rule of 9 says sum of digits must be divisible by 9 or in the form of 9n, that is a multiple of 9. So strike off all those values that you think are multiple of 9. So can I simply strike off 7 and 2? The summation would be 9. So these two goes out. Then we have 6 and 3, 9, sums up to 9. 7 and 2 sums up to 9. 4 and 5 sums up to 9. So all these values are taken out. What are we left with? We are left with 6 plus m. This must be divisible by 9. And in place of m, I can put any value of a digit. Suppose I put here 0. So it is 6 plus 0, not divisible. 6 plus 1, 7, not divisible. 2, 8, not divisible. But if I put 3, it becomes 9 and it is exactly divisible. So for m, the only exact value is 3. So 6 plus 3, we have 9 and that is divisible. Now I have the exact values of m and n. I'll just use these two values, put it here and get to my solution. Let's do this real quick. So we have 4. What are the values of m and n? M here seems to be 3. N we have 2. 4 into 3, 12. Plus 2 into n, that is 2 into 2, which is 4 root under. So this is root under 16 and one of the values for it is positive 4. Do we have positive 4 as one of the options? Yes. So we'll mark it and we'll move forward. Option A seems to be the correct fit. I was going a bit slow. I was not rushing so that you have the concepts with you. We have already discussed the rule of 8 and 9 extensively in our lecture. So if you are seeing this for the first time, I'd request first go and watch part 1 of divisibility rule. These homework sets are from part 1. Once we are done with this, we'll release part 2 as well. Alright, so moving forward. Next question. If the number 95m44n is divisible by 36, again a composite number, break this number into its co-prime factors. So can you think of any co-prime factors? Yes, 9 and 4. So the product of the co-prime factors must be equal to the number. That is how you break these values. And this becomes the rule of 36. Now, what is the divisibility rule of 4? You only check the last 2 digits. Rule of 4 simply means checking the last 2 digits. And these must be divisible by 4 or in the form of 4n. Next, what is the rule of 9? You already know. So easiest among this would be starting with the rule of 4. So take out the last 2 digits from here. That is 4n. Now in place of n, what are the possible values that you can put to make it a multiple of 4? So you can put n as 0. And this 4n would become simply 40 and this is divisible by 4. You can place 4 even and this should become 44, which is again divisible. You can also place 8 here and it would become 48, which is again divisible. In the previous case, just pay attention now. In the previous case, only one possible value existed. But here we had 3 possible values. It's up to us which value should we pick depending on the further constraint or conditions of the question. Here one of the constraint is or condition is maximum value of these 2 digits. So what do you think is the maximum value of n? 0, 4 and 8. 8 seems to be the maximum value. So I should be ideally going with 8. So for now, let's pick n as 8. Now, replace the number or the value of n with 8 and let's see what do we have. 9, 5, m, 4, 4, n. And in place of n, let's put 8 here. Take out all the multiples of 9. So this goes out. 5 plus 4 goes out. 8 plus 4 we have 12. So this becomes 12 plus m. Now think of what is the value of m that you can put to make it divisible by 9 or to make it in the form of 9n. 9n is basically 9 or 9 into 2, 18 or 27. So highest value would be 9, 12 plus 9, no values. But if you put here 6, this would be 12 plus 6, which is 18. 18 is divisible by 9. Now we have the exact values of m and n. This is 6 and it seems to be a maximum value. So just add them up because that is what we are supposed to find ultimately. We are looking out for m plus n. That is 8 plus or 6 plus 8 and that is 14. Option A seems to fit in. I hope this is clear. Alright, moving forward to the next question. Just give it a read, everyone. What do we have? We have this number and it is divisible by 88, where A and B are single digit integers. Alright, now rule of 88 says this number must be divisible by 11 and 8 both. Co-prime factors of 88. Now, if this number is divisible by 8, let's take out the last 3 digits, 6, 7B. If it is divisible by 8, think of a multiple of 8 that starts with 6. It is 64. So write here 4. What are you left with? You are left with 3. So write 3. Now 3 and B. What could be the next place of value of B? You can only put here 2. Because any multiple of 8 starting with 3 and it's a 2-digit multiple, it is only 32. Therefore, definitely the value of B is 2. The value of B seems to be 2 here. So option C is my correct fit. Now, suppose you had 2 here as well. That would have been a disparity. So what we'll do, we'll try and solve this question completely. Although for this set of options that I have, my answer is done in one single step. But I'll start with the rule of 11 as well. Rule of 11 says sum of digits at even places, EP, minus sum of digits at odd places, and these two can be switched because we are basically looking out for the modulus difference. If this value is equal to 0 or any multiple of 11, so multiple of 11 I'm denoting it with 11n, that is 11, 22, 33, anything. If the difference between two sets is in that range, we can always call that number to be divisible by 11. Alright, let's see what do we have here. So if I rewrite the number, it would be 4, A, 3, 7, 0, 9, 4, 2, 6, 7, and in place of B, I'll be writing it 2. Now, let's start by taking the sum of alternate terms. So 4 plus 3, 7, 7 plus 0, plus 4, 11, 11 plus 6, 17, 17 plus 2, 19. Now next set, 7, 9, 16, 16 and 2, 18, 18 and 7 is 25, 25 plus A. Now just think of this. Can you get these two to be equal? If these two are equal, in that case only you would be getting the value or the difference as 0. But that cannot happen even if you put here 0 or even if you put here 9. So ideally we are looking out for the difference being in the form of a multiple of 11, and the nearest value that can come up, that would be 11. So just think of what can you put in place of A to make the difference between these two sets as 11. So simple way is put 11 this side and add them up. So 19 plus 11 would be 30. You just need to make this set as 30. So it is how much lesser than 30? 5 less. So simply put A as 5. Now just think of it. This becomes 25 plus 5, 30. This becomes 19. 19 minus 30, what is the difference? Minus 11 or simply 11, because we tend to omit the negative sign. This is always in terms of modulus difference. We are only looking out for the difference and nowhere do we focus on the negative or the positive sign. So we have the value of A as 5, therefore A is 5 and B is 2. We had it in option C. And that is how you can always mark your questions. I hope these 3 questions are clear to everyone. No doubts here. Alright, moving forward. Next, question 4. If the 7-digit number is divisible by 72, 72 means it follows the rule of 9 and 8. 9 8 is 72. So taking out the last 3 digits, let's see what do we have here. 4B4. Now think of any multiple of 8 starting with 4. So these are multiples are starting with 4 is 40 and next one is 48, right? Now if I start with the first condition, taking this to be 40, so I'll write here 0. Now next, if I take it to be 40, next, or let's start with second one first, because let's see if this one would be possible or not. Even if I take it to be 48, I need to put here 8, and then maximum value for B would be 9. So even if I put here 8, 4, 8, 4 is not divisible by 8. And then if I put here 8 and this would be remaining as 1, 1 and 4 is not divisible. So second case is not possible. Just think of it. You will do the calculation, you will realize you cannot have this multiple being 8 here. So this case is omitted. I will only focus on making it 40. So if I make it 40, next value could be either 24 or 64. Now, if this is 24, in that case B would be equal to 2. If we are looking out for 64, in that case B is equal to 6. Now what are we looking at? We are looking at the least value of A and B. By looking at this constraint, I'll try to put B as 2. But these two are the possibilities. Now just think of it. 4, 2, 4 is exactly divisible by 8. Also 4, 6, 4, it is again exactly divisible by 8. I hope you are following this. Now, do we have a definite value for B? Yes, due to the constraint, we have the definite value of B as 2 because we are looking out for the least value. Now, let's write down the number. We have 5, 6, A, 3, 4, 2, 4. Okay, now let's cancel out all the multiples of 9. So 6 and 3, 9 gone. 5 and 4, 9 gone. 2 plus 4, 6 plus A. What can you put in place of A to make it a multiple of 9? Very easily you can put A as 3. So 6 plus 3 would be equal to 9. Right? So we have the value of A as well. It seems to be 3. What is the value of A plus B? A plus B means 3 plus 2, which is 5. Option C seems to be the correct fit here. Are you following this, everyone? Step by step, we are moving forward with the question. We have already started with few of these type of questions. I will discuss these in the part 1 of our divisibility lecture 2. Right? All right. Question 5th. The 10-digit number is divisible by 24. 24 means it must be divisible by 8 and 3 both. Starting with the rule of 8, let's take out the last 3 digits. What do we have? 0B8. Now, what could be the possible value for B to make it a multiple of 8? B could be either 4, it becomes 48, or 8. We have 2 possibilities for B. But look at the question. We are looking out for the least value. Therefore, we'll go with the first option, that is B is equal to 4. Now, let's rewrite this. So we have 2A6, 1, 2, 3, 4, 5. Then we have B. So I'll write in place of B as 4 and then 8. This must be divisible by 3 as well. So take out all the multiples of 3. You can take out 3, you can take out 6, you can take out 9. So I'm taking out 6, 4 and 2, We have 6. Now we are left with 8 plus a. In order to make it a multiple of 3, the least value that I can put in place of a would be 1. That is 8 plus 1 is divisible by 3. 9 is divisible by 3. So what do we have here? A becomes 1. A plus b. 1 plus 4, which is 5. Option A seems to be the correct fit. How you can eliminate this? Because of this constraint, that is least value. We are looking out for the least value amongst the following. And that is how we can easily eliminate certain values. Next, if a 10-digit number 2094x843y2 is divisible by 88, again this means it must be divisible by 11 and 8. For 8, we know take out the last 3 digits. So we have 3y2. Just think of it. Multiple of 8 which starts with 3, that is 32. Now ending with 2, you can think of so many possibilities. One of them would be 32. The other one is 72. And in this case, we are looking out for the largest possible value of x. We have no words regarding the value of y. So we have to take this as, suppose, 3. So if we write here 3, that means y must be equal to 5 in this case. Another possibility would be 3y2. This must be 232. Then you can also take 72. So for writing 72, we need 7 here. And 7 plus 2 is 9. Therefore, y would be equal to 9. Just think of these numbers quickly. 352 and this becomes 392. Just think of it whether these are divisible by 8 or not. Can you do that? Respectively, we can have the value of y as 5 as well as 9. Here we are looking out for the largest possible value, but it says for x and nowhere it is mentioned about y. So we cannot just simply omit this one or the other one. We have to go by both the possibilities now. So we'll do that, no worries. First case, I'm using y as 5. I'm rewriting the number 2094x 84352. And in the second case, I'm writing y as 9. So what does the number become? 2094x 84392. Apply the rule of 11. 11x 15 20 20 plus x. Another set 4 12 15 and 2 17. Just think of it. Can you make these two set as same so that you'd be getting the difference as 0? No, that is not possible. So ideally we have to make it in the form of 11n or 11. So if I want to make it 11, because that is the only possibility left, I need to add how much to this set so that the difference between these two is 11. Simply add 11 to this. It would be 28. That means I need to make this set as 28, and that can be done when I take x as 8. Just think of it. This becomes 20 plus 8. 28 minus 17, we get the value as 11. And that is how, if you put x as 8, this whole number, you can use the calculator and check, it is again divisible by 11 as well as 8. So using y as 5, we get the value of x as 8. Now we need to check here whether we would be getting the value of x largest or not in the second case. For x to be largest, we need to get the value of x as 9. Let's see. So I'll start with the simple calculation. 11x 15 plus 9, we get 24. And the next one is same, that is 17. Now tell me, here you had 20, here you are having 24, so you can only put x as 4. So out of the two possibilities, x here is lower value, x here is a larger value. So we'll start or we'll stick to this one and we'll ignore this one. Now, if we stick to this, what are the values of x and y? X here seems to be 8, y seems to be 5. Now use this in our equation. 8 5s are 40 minus 7 5s are 35. We get the difference as 5. Do we have 5 as one of the options? Yes, option A seems to be the correct fit. This case is being ignored, but this can be ignored once we are done with the calculation for x and not before that. Alright, I hope this is making sense to you all. Let's start with the remaining pending questions. 7, 8, 9 and the 10th one. Alright. Now 7th is a bit different. Although the concept is purely same, but I think I haven't discussed a question based on this type. So please pay attention everyone. In the lecture I have not discussed. That is why I have put few questions in the homework so that we have clarity about the different types of question that can be a possibility in our upcoming exam. Okay. 676 xy is divisible by 3, 7 and 11. All three are prime numbers. So first step would be taking the LCM of all three. Even if they are prime or composite, does not affect. Since these are divisible by these numbers, so always take the LCM of the remaining values. So this is 3, 7 and 11. So LCM would be 3 into 7 into 11, which is 7 3s are 21, 21 into 11 is 21, 21, 231. Now, please understand. If this number, that is 676xy, is divisible by, in terms of 3, 7, 11, we can write divisible by 231. That means it is equal to a multiple of 231. Do you agree? 231n represents a multiple of 231. So basically 676xy is a multiple of 231. Now, based on this logic, I can start with certain assumption. So what is my first assumption? Let me just put x and y as the highest digit values. Let's put x and y as 9. And let's take the remainder here, if any. Suppose, what is the number now? 67699. If this is exactly divisible by 231, so my answer for x and y would be 9 and 9. Now whatever the remainder that we get, if we subtract the remainder from here upon dividing it by 231, that would be my multiple of 231. So that is what we are looking out for. We'll see how this can be done. So bear with me now when we start with this calculation, that is 67699 divided by 231. So it will go 2 times 462. What is the gap? 4 and 1 and 2. 2149 comes down. 231 into 9, or we can write it as 231 minus 231. 2310 minus 231, that is 10 times minus 1 time is 9 times. So this is easier to do. 4, that means 11 minus 4 is 7. 2079 9 times 0 0. Okay, 70. Now the 9 comes down and 3 times it would be 3 3s are 9, 3 2s are 6. So we have 6. 10 minus 9 is 1. and the 1 0 comes here, so it is 16. Now 16 is my remainder. That means this number 67699 is not a multiple of 231. But if you write 67699 minus the remainder, that is 16, now the number that you get, that is 3, 8, and this is 676. This number is in the form of 231n. And that is what we were looking out for from the start. Right? Now what are the values of x and y? Therefore, x is equal to 8, y is equal to 3. Now let's use it here in our equation. 8 into 3, 24, minus 5 into 3, 15. We get the value as 9. Option D seems to be the correct fit. Now you might argue that if 6783 is a multiple of 231, we can have so many multiples of 231. Why did we stick to this part? If you subtract 67683 minus 231, because the next or the previous value that would be a multiple would be 231 less. So you would be getting 2, we would be getting 5 here. But see, this 6 will also change to 4. This cannot be done because the number is 676. These 3 digits don't change. X and Y we don't know, so we can change that part. But 676 must be intact. Therefore, this is the only possibility left, and that is how we can mark this question. I hope this helps. We'll do 2 more questions based on the same type so that this concept is easier to follow for you all. Alright. 3, 7 and 11 again. So 3, 7 and 11, you know the LCM is simply 3 into 7 into 11, which is 231. Now, the number that I am looking out for, which is 489, and in place of AB, this must be divisible by 231, or 489 AB must be equal to 231 n. That means this number is a multiple of the other number. I hope you are following this. So what we do, we start with our basic assumption by putting A and B as 9. So put these two as 9 and let's see what is the value that we get. Putting these two as 9, we get the number as 48999. Now let's divide this with, what do we have? 231. So 231 2 times would be 462. So this is 7, this is 2, and the 9 goes down. One time we'll get it 231, 8, 4, 489. Again 2 times we get 462. What is the difference? Let's see, 7 and 2. 27 seems to be my remainder. Now, the exact number that we're looking out for, that would be 489. These 3 digits cannot change. And in place of AB, I'll write 9 and 9. This is not a multiple of 231. But if I take out the remainder from here, remainder is 27. Now what is the number formed? 2 and 7. And then we have 489. So in place of A and B, the values are 7 and 2. And if you look at this number, this is equal to 231n. Or we can say 48972 is divisible by 231. You can always check with the help of calculator. Do these because that is how you try to relate with the question. Always cross check and relate, and that is how you can follow a question like this. Alright, moving forward to the next or the penultimate question for our session. Again, based on the same type, and how do we take the LCM? Simply multiply all the terms. So we have 7 into 2 cube into 3 square, or 8 into 9. So we have 72 into 7. 9 8 is 72 into 7. We have 7 2 is 14, 1, 7 7 14, 0. It is 504 or 504. What is 504? The LCM. Now, how we can proceed further? 5, 2, 3 will never change, but in place of A, B and C, we can take them as 999, or we can write it as this is a multiple of 504n. That is how you show the multiple sign. 504n means it's a multiple of 504. Now, putting A, B and C as 9. What is the number that we get? 5, 2, 3, and then putting ABC as 9 is 999. Now let's divide this by 504. One time we get 504. 23 minus 4 is 19. 1 9. Another 9 goes down, so 0 here. Now 504 into 3 would be 4 3 is a 12. So 1512. Subtract. This is 7, this is 8, this is 4. Take down the 9. 9 times it would be 9 4s are 36, 9 5s are 45. Subtract. This is 3, this is 4, this is 3. 343 is our remainder. In this case, let's just cross check. 3, 7 minus 3, 4, 8 minus 5, 3. Okay. What should be our number? So 5, 2, 3 does not change, and in place of A, B and C I have put 9. Take out the remainder, that is 343. The number formed is 6, 5, 6, 5, 2, 3. Now this is one of the cases. So let me just put A, B and C as 6 into 5 into 6, which is 180. Do we have 180 as the option? Yes. So that is my correct answer. I hope this is clear. Now you can also argue, but you can always take out 343 from here as well again. If you do that, what do you get? You get this as 3, this as 1, and the next number as 3. Do you agree? Sorry, not 343. 343 is the remainder. Yaar. You can always take out 504. Because see, this is a multiple of 504. Right? Just think of it. It's in the form of 504 into some value. Right? Into 1039. 504 into 1039. N here represents 1039, the quotient. This is equal to this value. Right? Now, if you take out 504 from here, it would be something like this, where it is 2, it is 5, it is 1. And then you have 523. This 523 does not change. So we can have a possible value of A, B and C as 1, 5 and 2 as well. And if you consider this case, then my answer would be A into B into C is 1 into 5 into 2, which is 10. Do we have 10 as the option? No. Therefore, we have to ignore this second possibility. In the previous two cases, there was no scope for the second possibility. Because if you take out 231 from here, you are changing this digit as well. If you take out 231 from here, you are changing this digit as well. And that cannot happen. But here, if you take out this 504, it does not change. But if you do it now, it would change. So we have two possibilities or two numbers which are multiple of 504, that is following the constraint of the question. But due to the option, looking at the option, we don't find 10. Therefore, I'll go with the first case. It's not like the second case is not possible. It is 100% possible, but then you see the option and that is how you mark the question. I feel this is clear to everyone. If you have any queries, please comment down. I'll try to solve those queries, because please understand, do not leave out any of the questions. All these questions are important, and for you to tackle this and understand this can only help you to grasp the concept. So if you look at any question on CSAT for this year and the trending previous years, most of the questions are based on application of the concept that you have already learned. Right? Moving forward to the last question for the set, the 10th question. If n is a whole number greater than 1, so the possible values for n would be 2 or 3 or 4 or 5, and it can continue, right? Now in all of these cases, what are we required? Then n square into n square minus 1 is always divisible by which of the following numbers? So what are the numbers in option? 16, 12, 10 and 8. Alright, let's be quick. Now, if you put n as 2, so this is 2 square, 4 into 4 minus 1, which is 4 into 3. Is it divisible by 16? 4 into 3 is simply 12. Is it divisible by 16? No. Is it divisible by 12? Yes. Is it divisible by 10? No. Is it divisible by 8? No. We have got our answer in step number 1 only, that is 12. But if you want to check further, you can always check. 3 square is 9, 9 into 8. 9 into 8, 9 8 is 72. It is not divisible by 16. Is it divisible by 12? Yes. Is it divisible by 10? No. Is it divisible by 8? Yes. But you get the idea that all of these numbers would be naturally divisible by 12. You can always check. Next up, we can have 4 square, 16 into 15. This will also be divisible by 12. Next up, we would be having 25 into 24. That is also divisible by 12. Next up, we would be having 36 into 35. That is also divisible by 12. I hope you are following this. 12 seems to be the correct fit. This was the solution of part 1, all the pending homework question, lecture 2 on divisibility. Alright, keep learning, keep posting your queries. I'm there to solve all your queries. Happy learning everyone. Take care. Bye-bye. See you all in the next video.